Testing 1, 2, 3. Hi, Mr. Motors here. What I want to talk about now is a number system called hexadecimal. So this is going to be discussing about hex decimal. Let's see if I can make that. I don't know if I can make this font size bigger or not. Hexadecimal. Hexadecimal is derived from two, I guess, root words. Hex meaning 16 and decimal meaning 10. So if you put hexadecimal together, you get 16. Okay. Um, Let me take a look at something here. I'm trying to change my little font size, but evidently I can't. Okay. Hexadecimal has been developed by was developed by programmers in the 60s, probably, well, 40s, 50s, 60s, somewhere along in there, as a means to take a group of bits and chunk them together in groups of 4. If you take 2 and raise it to the 4th power, you get 16. And so that's where hexadecimal kind of comes in. There's 4 bits that taken collectively equal 1 hexadecimal value. Now in hex, I'm going to put an H and a D for decimal. Let's spell it out actually. Hex, DEC for decimal, and BIN for binary. Now the hexadecimal values, the 0 is a 0. The 0 in hex is a 0 in decimal. And it's also 4 bits in 4 zeros in binary. Let me see if I can get all my numbers in here. 2, 3. I don't think I'm going to be able to do it. Let's just do a few of them. 9, 10, 11, 12, 13, 14, 15. That looks pretty good. This right here, the dot, 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 means we're not going to be able to put them all in there because I ran out of room. Okay, but you can get the idea. 0, 0, 0, 1. All right, just a minute. There's a pattern flowing. Remember, this is 1, 2, 4, 8 from left to right for the binary digits. So 3 is going to be 0, 0, right? 1, 2, 4, 8. So 1, 1. So the 1 on the far right is 1. You have to go back and listen to my decimal to binary and binary to decimal lectures to understand this. Okay? And now let's go on down. 9 is 9. And 9 is going to be 1 for 8, 0. I don't need the 4, I don't need the 2, and I need the 1. Okay? Now, when it gets to the 10, here's where it gets a little different. Okay? So, give me a minute for this table. 0 through 9 is the same in decimal and hexadecimal. And 10 in, oops, I got them backwards. A 10 in decimal A 10 in decimal is an A in hexadecimal, which happens to be 1010 in binary. Okay. Uh, what it does is, since we're only going to group 4 bits at a time, yet in decimal that's 16 values, 0 through 15, 0 being a value. What we're doing is we're going to have to use letters on the keyboard or something else to represent the 2-digit numbers 10 through 15. So they pick A, B, C, D, E, and F. Okay. So it looks like this. And B is 11, and 11 is 8 plus 3. 8, 9, 10, 11. 12 is, guess what, A, B, C. And 12 is going to be 1, 1, 0, 0. 8 plus 4. Again, you need to go back and listen to my decimal to binary and binary to decimal chats on, or virtual lecture that's in the course. 13 is going to be 8, 9, 10, 11, 12. 8 plus 4 plus that's 8, 9, 10, 11, 12, right, plus 13. And 14 is E, which is 8, 9, 10, 11, 12. There you go. F is 15, and that's all of them. Okay? So these are my, again, you're going to have to fill in the blank here, 4 through 8, but you can do that. You can go to the internet and find these, and so this is our table we have to use, okay? Our table we got to use. Now, having said that, let's take a number up here, like, let me back up. 10 in decimal is A in hexadecimal, and is 1010 in binary, okay? Let's just pick on 10 for a minute. All right, there's 10. Now, how do I know this? Well, remember, this is the 1 position. This is the 2 position. This is not working. Let's do this one more time. Hang on 1 second. That might be a little better. See the values a little bit? Let's play with this here for a minute. Well, it doesn't like me doing that, so I'm gonna go back to my normal size. I was trying to change the font in here, but you guys know how because I can't find it. I'm not trying to. I don't want to waste too much time. Um, Attributes maybe. No, I want to change the font size. Anyway, maybe it just doesn't like me doing that. 1, 0, 1, 0. Okay. This is the 1 position. This is the 2 position. This is the 4 position. This being the 8 position. So you see how it's equal to 10? You add up all the ones that are turned on. That's what gives you the 10. This is a little bit of review from our last decimal to binary, binary to decimal discussion. So if I were to give you a question and say, I want to know what 12 decimal is in hexadecimal, you would turn around and say, well, that value is, what's the value of 12 decimal in hex? C, okay? Or 1100, which is 1100, which is 1248. Now remember, this is 2 to the 0, 2 to the 1, 2 to the second, these little arrows, and 2 to the third, all right? So it's 8, 9, 10, 11, 12. That works out. Okay, let's say I had a big number, 1, 1, 0, 1, 1, 1, 0, 0, and I wanted to turn this binary number into hex. What do I do? That base 2 down here means it's a binary number. What do you do? Well, you move from right to left and you divide them into chunks of 4. So then I got to take each of these and convert it to its own decimal value. So 1, 2, 4, 8, that's an 8, is 12. That's the decimal value. Uh-oh, might be C. And this is going to be, of course, 1, 2, 4, 8, and that's going to be 13, right? So then I got to take the 12, do a table lookup, this being my table over here, and that's going to be C, and this is going to be D. So the result is DC base 16. How about that? All right? It's not 1312. That's not an answer. It's not 1312, even in binary. Even in decimal, it's not. It's DC. Okay? Thank you very much. We're going to continue this idea. This is Todd Metters, copyright 2007.